Researchers from University of Copenhagen, Denmark have developed a new technique that keeps quantum bits of light stable at room temperature instead of only working at minus 270 degrees. Their discovery saves power and money and is a breakthrough in quantum research. As almost all our private information is digitalized, it is increasingly important that we find ways to protect our data and ourselves from being hacked. Quantum cryptography is the researchers' answer to this problem, and more specifically, a certain kind of qubit consisting of single photons, that is, particles of light. Single photons, or qubits of light as they are also called, are extremely difficult to hack. However, in order for these qubits of light to be stable and work properly, they need to be stored at temperatures close to absolute zero, that is, minus 270 degrees Celsius, something that requires huge amounts of power and resources. Yet, in a recently published study, researchers from University of Copenhagen demonstrate a new way to store these qubits at room temperature for 100 times longer than ever shown before. The researchers say that they have developed a special coating for their memory chips that helps the quantum bits of light to be identical and stable while being in room temperature. In addition, the new method enables them to store the qubits for a much longer time, which is milliseconds instead of microseconds, something that has not been possible before. The special coating of the memory chips makes it much easier to store the qubits of light without big freezers, which are troublesome to operate and require a lot of power. Therefore, the new invention will be cheaper and more compatible with the demands of the industry in the future. The advantage of storing these qubits at room temperature is that it does not require liquid helium or complex laser systems for cooling. Also, it is a much more simple technology that can be implemented more easily in a future quantum internet. The coating consists of a paraffin that has a wax-like structure, and it works by softening the collision of the atoms, making the emitted photons or qubits identical and stable. Also, the researchers used the special filters to make sure that only identical photons were extracted from the memory chips. Even though the new discovery is a breakthrough in quantum research, it still needs more work. The researchers says that right now they produce the qubits of light at a low rate, 1 photon per second, while cooled system can produce millions in the same amount of time. But they believe there are important advantages to this new technology and that they can overcome this challenge in time.